it knows I'm presenting or something. It just gets nervous, you know? Okay, well, I'm just gonna start. Welcome everybody. I'm so excited for this meeting. Um, our first present. Um, well, this is just a reminder that there is book club after this meeting. We are talking about how to be a more inclusive teacher. And then,
Mary, do you want me to share my screen?
I am so sorry. I don't know why it's being like this.
No worries, no worries. Just thought I would ask. So
Yes,
you
please.
don't have
Thank
to
you.
freak out. I'll do it right now.
We are so lucky to have. So we, after the book club, then it's the we have a guest speaker, Rick Erickson. Then we have in the field outreach. So we are so lucky to have Rick Erickson here with us today. He went to school at the University of Minnesota at Duluth. He taught in Minnesota for a couple years and currently serves as a teacher in Bayfield, Wisconsin. I've had the pleasure of working with Rick and his wife Lori this year on WEAC's Quality Education Committee, where Rick serves as the head of the committee. We are so excited for you, Rick.
Awesome. I'm glad to be here. Thank you.
Do you want me to share your slides or do you want to share your slides?
I can try. I'll try and share them and see what happens.
That sounds
This has
perfect.
been awesome. Yeah, and this has been great to watch the technology fumble through, because that's what it's been like these last several months teaching, right? So, all right. So I'll give you a little bit of background, but let me try and see what happens here. If I can get my screen up, so you can tell me if are you seeing that?
Yes.
Yes.
Okay. All right. Well, let me tell you just real briefly about me, and then I'll get into this and hopefully what I'm going to try to do while I'm here. So, like Mary said, I've been teaching for 37 years. I taught for 10 years in Minnesota. I'm currently teaching in Bayfield. I'm a chemistry physics teacher by trade, but for the last 8 years, I've also been teaching a high school alternative education program. So, so I teach the alternative education program in the morning to 13 high school at-risk students, and then in the afternoon, I do chemistry and physics. And so my background, actually that'll come up. So I think maybe I'm just going to start and then that'll come up when I talk about these things. So I believe what I was asked to do was to come here to talk about equity in science education. And this could apply to anything. This isn't just science, but it's about equity. And I want to, and that can mean a bunch of different things. And I know that people have come into this, we've done this workshop a couple of times and people have come in with different idea about what it is. And so, so I'll tell you about what we think it is, although it could be a lot of other things. So Kevin Anderson is the Department of Public Instruction science consultant, and he wanted to organize a work group around the idea of equitable access to all students in the state of Wisconsin in science education. So it's about creating a science program that is accessible to everyone and hopefully encourages everyone to pursue science in whatever capacity they want to pursue it. So, so there's a group of people, maybe 20 of us or so across the state who were meeting over the summer once a month or so to talk about equity, and we broke into subgroups. And the one of the groups that I'm in is dealing with professional development. How do we teach people how to address equity in science education, and how do we teach people to make science more accessible to everyone? And that could mean how do we encourage people to go into it? It could also mean how do we develop systems that have equal access as far as equipment and teachers and all of that stuff. So it's a huge array of things, but primarily we're talking about making science accessible to everybody. All right. So we actually developed this program to be like an hour and a half. We did an hour program for the WEAC's Professional Development Institute. I'm going to cram it into a half an hour, but actually for you guys, this is going to be fine because you have a huge advantage over people who've been in the career for a long time. I'm so impressed with educators who come in to the field now and with aspiring ed students. You have the language is different. The things you talk about are different. You're addressing things in a totally different way than when I came into the profession. So I can whip through this first part very fast. So I'm going to put it into the full slideshow version, hopefully, maybe. And wait, there we go. And see if this works. Yeah, like I said, I've been teaching for 37 years. I am not a tech person at all. So when I first came into teaching, there were no computers in the school. So things have totally changed, and we've had to adapt to all of that. So here's what we're hoping to do in this program is it starts with identifying who we are individually. And so that's what I'm going to do quickly, because you guys already have that. You probably do that so much that, you're heads and tails above where people at my place in my career are right now, or were. And so now, is this going to let me change slides? No. Okay, I might come out of the full view and see what happens here. Oh, there we go. It's just slow, that's all. I'm sure you've all seen this slide before, and I just want to make a real quick point about this. We showed this slide about equity because we're talking about equity and not equality, and we don't need to get into this, but we see the boxes that are equal on the left, and then we see everybody having a view on the right. And the last time we did this presentation, it was great. People started asking other questions. They're like, yeah, but you guys aren't diving into it deeply enough. So these are the questions that other people came up with. It's like, how do we get rid of the fence? Why do we even need those boxes? Who's actually on the inside? How come there are people on the outside? Who are these people on the inside? Why do they get to be inside while these people have to be outside? Who's even getting to play the game? How come these people aren't involved in the game? So this isn't equitable just because they can see the game. And then the big one that I really liked was, and who's making the rules? Who's deciding who's inside and who's deciding who gets to play? And so that diagram is a great diagram that at least gets us thinking on the idea of equity, but it really just raises way more questions than it does anything. And then here's another way to view it. And so we had this discussion a little bit about, what is equity? And I have a colleague who teaches down in the Milwaukee area. She's an elementary school teacher, and she put things into perspective for me about 10 years ago in a way that I've never forgotten, and I use it often. She's like, all these diagrams are awesome about equity and equality, but I just simply, when I teach my second graders and they say things like, hey, that's not fair, you're treating somebody differently, I just say eyeballs, and they all know what I'm talking about. And so I asked her, like, well, what does that mean? And she said, we as a society, we totally accept the concept of equity when it comes to vision. If somebody has vision issues, everybody gets their own prescription. It's specific to that person. We don't give everybody the same prescription and say, hey, we're treating everybody equally. We acknowledge that everybody's vision is different. And so we give them all whatever it is they need to be able to see to the best that we can. And she said, but we don't do that in education. We don't do that in athletics. We don't do that in any other thing. But for eyes, we seem to get it. So anytime anybody talks to me about things not being fair, I just say, eyeballs. It's not about being fair. It's about trying to help everybody to do the best they can do. So I talked about this self-reflection, and we're not going to spend a lot of time on this. I just want to say that at the beginning of the program, what we usually do, we just want people to think about who they are and what do you come into teaching with? What are your ideas? What are your, we all have prejudices. We all have different views of things. We all have biases. And it's real important for me to know I am a white male who has been teaching for 37 years. I'm in a demographics right now that a lot of people would see is not a great place to be, an older white male, for the way that that particular demographic happens to think at this particular point in our history or whatever it is. But that's my perspective when I come in. Yet I'm teaching in a school district that is about 85% Native American. And so it's very important for me to be able to acknowledge who I am before I can attempt to address the needs of my students that I have in the classroom. And so that was one of the things I wanted to make real clear, is that you need to know where I come from as far as my background in teaching. So I've taught only in 2 districts. Those are my only 2 perspectives. They're very different. The district I taught in Minnesota was a very white, affluent suburban school district that was highly sought after. People wanted to get their kids there. Open enrollment was how they that was the name of the game for them, was to bring people in because of their academics. Now I teach in a school district that's rural. It has, like I said, 80% of the students are Native American, they're Anishinaabe. About 75% of the students qualify for free reduced lunch. About 30% of our students are on IEPs. We have a very specialized population. It's a very unique group. It's a group that has a lot of exceptional needs students in it. And again, like I said, I'm a non-native teacher teaching Native Americans. And in Wisconsin, that's part of reality, right? We are a very white state, yet there are districts that have high minority populations, and we need to be able to address those needs as white educators in the best way we can. So it's knowing who we are before we can address the needs of our students, okay? And one of the things that I learned while I was here that's been super valuable is because my question was like, what do I do about Native culture? Because I know it's super important for our Native students to be in touch with their culture and to have access to their culture, but I'm not Native. And so it was always a question for me, like, where do I fit? How do I deal with this? How do I address this? And I learned at a meeting with elders fairly early in my career here in Bayfield that, and they were very clear to me, it's not your job to teach culture. Again, this is my perspective. This is what I was taught. Doesn't mean that this is right, but what really helped me was for them to tell me, it's not your job to teach culture. We appreciate that you bring culturally relevant materials into the classroom, and we appreciate that you acknowledge the culture and that you bring elders into the classroom to help your students, but you don't need to teach our stories. You shouldn't be teaching our stories. You shouldn't be teaching our culture. That's our job to do that as a community. And so that took a huge weight off my shoulders when I recognized that, or when I was told that. And so that's part of my journey as to where I am right now. All right. So that's just, so the beginning of this really, like I said, is about identifying who we are. Where do we come from? How do we address students from our perspective? And then we move into, okay, so how do we bring that into the classroom? How do we provide equitable science education? And as far as resources go, the next generation science standards, and I'm going to guess this is true of just about every content area, there are some really good people who have put a lot of time into developing these standards. And they don't just develop the standards, but they develop a lot of supplemental material around the standards. And so the science standards have a lot of great resources in there that talk about addressing the needs of all students. And how do we frame scientific questions so that we encourage all students to be part of the discussion? And hopefully I'm going to do that in the second part, or in the last part of this thing. So these are some resources. I did share the PDF version of this slideshow with Mary so she can get it to you. So all these resources should have active links in there. I think even in the PDF version. There are some key points that are listed in the next generation science standards, that learning is cultural. Instruction should leverage science related values. So it's not just about science facts. And that's one of the things that's really changed in my career. When I came in, I was taught how I was very content oriented. I learned about the content of chemistry and physics. And over the time period of my career, science education has evolved to not be so fact oriented and so content oriented. But if you're familiar with next generation science standards, it's about weaving together content with cross-cutting concepts that you see in all sciences, like how do you make observations? How do you process information? And then the practices of science. So the next generation science standards have 3 pillars to them: disciplinary core ideas, cross-cutting concepts, and the scientific practices. And we've always done those things in science. I think good science educators have always done those things, but the next generation science standards formalized it and tried to get across the point that those three pillars are equal pillars, and we need to include all three of them when we're doing our science instruction. And so that's a great place to start with. How do we do that? Then I'm going to whip through some of this stuff so I can get to what I think really matters. So, so here's part of what matters, recognizing that, and you guys all know this too, I don't need to spend a lot of time on this. This isn't anything new, but things are, everything is cross-categorical, right? Science and math and ELA, they all fit together. Social sciences fit together. Everything all fits together. And so looking at things from a slightly different perspective, where we're not just looking at science, but we're looking at how does that interact with other disciplines, is real important. There's a great link on here. If this is going to let me go past this, I'm not going to show this, but there's a great link about why we shouldn't just be focusing on ELA and math, where we should be focusing on a broader array of things. So this is where I'm going to hit the meat of this in these last 10 minutes or so. So one of the things that the next generation science standards talks about is, one of the ways you can address equity in the science classroom is use the students' interests and use phenomena in their place to drive home concepts. So it's about being place-based and about using what students do on a daily basis. And so if you're science educators, or even if you've taken science classes, you might have science education classes, you might have heard about phenomenon-based education. And so that's kind of that's the direction I'm going to go with this, is using phenomena to address the teaching of science as a way to bring equity into the classroom. All right. So, and this is just a nice little graphic that shows these are the 8 scientific practices that we try to teach in science. So I'm not just teaching chemistry and physics concepts. I'm teaching them, how do you plan and carry out investigations? How do you ask questions? How do you develop models? How do you engage in argument from evidence? So this is kind of the drive that next generation has been pushing, is getting science teachers to teach from this lens rather than just teaching facts and concepts. And then using that to talk about how do you make sense of things? Because really, when it comes down to it, we're all curious people. And so it's all about, we want to know why things do what they do. And unfortunately, through my career, I've seen a lot of kids turn off to science because we really take the science out of science. Science is about observing what happens around you and learning why those things happen, making sense of those things. And instead, what we did for a long time was pound things like the periodic table and Newton's 3 laws. And not that those things aren't important, but we need to put them in perspective about why they're important. So, okay, so here's the meat of it. So what I like to do in my chemistry physics classes is I use student questions as driving questions. And if somebody, because students have questions all the time, and if they come in and they have a question that's not pertinent to what we're talking about at the time, I still address them and I still talk about it, but I'll keep in my mind for a later time, like, where can I use this to really investigate this? And I love using student questions to set up experiments. So yes, I have a chemistry lab book, and yes, I have a physics lab book, but I usually do my chemistry and physics labs based on what students ask, because they are the same questions, they are the same concepts. So here's an example of that. This is something that probably every person has asked or thought about at some point or heard. It's like, oh, hot water freezes faster than cold water. So inevitably, I'll have a kid come in and ask me that. It's like, hey, Mr. Erickson, I've heard that hot water freezes faster than cold water. Is that true? Okay, back in my early days, I would have just answered that question. And now I say, I don't know, what do you think? And then I'll get a response, and I'll be like, you know what? That's a testable question. So let's test it. Let's find out. Does hot water freeze faster than cold water? So instead of me just giving you an answer, or instead of you looking it up on the internet, let's try it out. Let's actually get some data and that we can, so we have evidence. So the next time somebody asks you that question, you can show them evidence for your answer rather than just saying, oh, I read it on Wikipedia, or Mr. Erickson told me, or whatever. So this is a curve. So when we start this investigation, we'll just start with a cup of water and just have them so we use like a data collection device. So it's collecting water temperature every 10 seconds or 20 seconds or however they choose to set it up. And just so we can see what happens to water when it freezes. And so you can see that this one started at about 23 degrees Celsius or something like that. We put it in the freezer. The probe is in there the whole time. The temperature drops just like you would expect. When it gets to 0, just like we would expect, it starts to freeze. And when things change phases, their temperature stays constant. So energy is still being removed, but it's not cooling anymore. Now the energy being removed is helping it to form the bonds that it needs to form to make ice. Once it's totally frozen, it's going to drop away from that plateau. And so the kids can see that somewhere in here, that water that we had in the freezer was totally frozen. So now we have to frame the question. So when you ask the question, does hot water freeze faster or slower than cold water? I want you to define to me, what do you mean by that? Do you mean like, is this plateau longer or shorter from the beginning to this point where it drops off the plateau? Are we looking for that time frame? So you need to define for me, what do you mean by freezing? So the kids are involved in that discussion, okay? Once they've done that, then they set up an experiment where they have 2 different temperature waters. They put them in the freezer, or they could do 3 or 4. They get to decide. And so here's an example of student data where you have 2 water samples, one that starts a little bit above 60 degrees Celsius, one that's starting at about 23 degrees Celsius. You can see them both go down. The cooler one gets to its freezing temperature faster than the hot water. And you can see that the cold water drops off the plateau sooner. And so then once they get this, I ask the kids to interpret it. What does it mean? And typically they'll say, well, according to this information, the cold water freezes faster. This also raises a ton of other questions. You can see these real cool little sinusoidal things at the end. The kids are always like, well, what's that? What's going on there? And so we have a discussion about it. And eventually they come to the realization, it's like, oh, that's how a freezer works. A freezer turns off, it turns on, it turns off, it turns on. And so we're seeing those temperature fluctuations as the freezer is turning off and on. Okay, so this is like, so a group gets this and they say, nope, cold water freezes faster. Well, that makes sense. It's closer to the freezing temperature. Then another group comes up and shows me data like this. And it's like, you look at this one, and this one, it looks like the hot water is dropping off the plateau sooner. So here they actually reached the freezing temperature at the same time, but the hot water dropped off sooner. And so this group tells me that according to their data, hot water freezes faster. And so this is a great discussion, right? Because just like often is the case in science, there may not be a definitive answer to this. Now there's a question about, well, how did you conduct your experiment? Why did you get different results than this person got? And so it's a great, and this has nothing to do with Anishinaabe culture. What this has to do with is that this is an equitable lab in the sense that everybody freezes water. Everybody knows what it means to freeze water. This is an accessible lab. It's a question that it's a question that kids understand. It's a question where they can design a lab because they understand how to control it. They know that they need to use the same amount of water. They know they need to put it in the freezer at the same time. They know that they need to be able to have 2 different temperature probes that are calibrated correctly. And so this is an accessible lab to them, to most students. And so working in groups, every group typically is able to design an experiment to test their hypothesis. I'll give you a quick little summary on this one. What these 2 groups found was that this first group put covers on their glasses of water when they put them in the freezer, and this group did not put covers on their water. And then once these 2 groups realized the difference in the way they conducted the experiment, they decided to redo it, doing it the same way that they had, but they also then measured the volume of water at the end. And it turns out that this one that had hot water, it was evaporating more rapidly than this one. So when they got done, there was a lot less water in the cup that started as warmer water. And so yes, it froze faster, but it's possible that it froze faster simply because there was less of it, because there was a lot of evaporation happening with the warmer water. So it's a great activity that just brings up a lot of other questions. So that's one example of a phenomenon-based science lab. All right. Before I do a few more, I want to go back over these things because these are questions I often get. How do I choose relevant phenomena? My answer to that, it needs to be relevant to the kids, their community, relevant to everyday experiences. And if kids ask the question, then that's a good phenomena, especially if it's a testable question. Can I design a lab to test this? Where do I put this in my curriculum? You can put it anywhere. It's a great example of scientific practices, which is part of our next generation science standards. You could incorporate it into an existing lesson. It could be its own lesson. You can put it in all kinds of different places. I put that one when we're talking about phase changes in chemistry. Does it impact achievement and address equity? I believe it does, and the data from next generation says, yeah, when you do experiments like this, where kids have access to it and it makes sense to them, you're not doing an experiment about the endoplasmic reticulum that they can't even visualize. They don't know what it is. And so these are things that kids, not that you shouldn't do those things also, but these give kids an opportunity to access something they're familiar with. So these are some other examples to wrap it up. We run a sugar bush where we make maple syrup every year in my alternative ed class. And every year we conduct an experiment because every year kids have questions. Does the sap flow up or down? I'm like, I don't know. Can we design an experiment to figure that out? Does sap flow in other trees besides maple trees? It's like, I don't know. Let's conduct an experiment and find out. Does sap flow better on the south side of the tree? That's what my grandpa and grandma say. They say they tap the trees on the south because that's where the sun hits it. Does it matter? I'll be like, I don't know. Let's do an experiment and find out. And so the kids design experiments to test their hypotheses or to test their questions better. All right. Or sometimes kids will bring me a photo and be like, Mr. Erickson, look at what I just saw. What's going on there? I'll be like, I don't know. Let's talk about this. And so phenomena like this that kids have access to, that they see, those are great discussion items in class. Those are some radio-collared wolves in our area from 2 different packs. We got this photo from a biologist in the area, and the green dots are from a wolf in one pack, and the red dots are from a wolf in another pack. And it does a great job of showing territories. But when I put this slide up for kids to look at, oh my gosh, the questions were crazy. It's like, how come there are some red dots in the green area, but there are no green dots in the red area? And so again, it's like, I don't know, let's talk about that. Let's bring in a biologist and have some discussions. What do you think about that? It doesn't just have to be in rural areas. I've had people ask questions about, I have students who ask me questions about how come it's always so foggy in Milwaukee. And so I'm like, that's a great question. That's a great phenomena. Investigate that. Have your students talk about fog in Milwaukee. Or this is a cool one. Actually, it was a PhD biologist who brought me this ice cube tray one time and said, what the heck is this thing? It looks like it's a stalagmite on my ice cube tray, but there's no dripping in my freezer. How did this form? And so we have some great discussions with kids about, because this actually is not an unusual phenomena, but it's a real cool thing that, again, talks about phase changes. In physics, there are all kinds of examples. This is a video. It's a cool one. Again, there's a link that talks about what happens if you drop a slinky. You're holding it off the ground and you just let go of it. Does the whole thing fall to the ground? And if you watch this frame by frame, what you see is that the bottom of the slinky stays right where it is until the top collapses onto it, and then it falls to the ground. And it has to do with the balance between the tension forces and the gravitational forces. Again, a cool phenomena. These are some resources that you can take a look at that talk about phenomena-based science. The DPI has an equity website. Kevin Anderson, who is the DPI consultant, put together a website on science equity. So that link is in that slide deck also. Wisconsin science standards have a section on phenomena-based science experiments or science discussions. So you have access to those if you want to look at them. All right. We're at 7 o'clock-ish, so I'm gonna pull out of that and stop sharing. We're at 7:01. That was fast, but I'd take questions, or if anybody has any comments or anything, that would be awesome.
I have a question. So, well, one, it was super cool to listen to you talk about this because I'm currently in a science class where we're talking about equity and sense making and stuff. So it was really cool to hear you talk about it too. My question is, when you're creating lessons based on students' ideas, are you more having to like make lessons on the fly, or do you have pre-planned lessons ever for your science class, or how does lesson planning fit into this?
That's a great question. Okay, so I'm just going to be totally honest and tell you I've never been a great lesson planner. So I have a ton of experience in the classroom, and yes, I have plans. I mean, I make plans. I have I have a big picture view. I know where I want to be at the end of the year. I have a flow of where things are going to be. But I'm going to also say that in 37 years of teaching, I've probably never taught physics the same in any 2 years, or chemistry. I've covered the same material, but I've probably done it in a different way. And so so as an example, like I have an idea of where I already want to put, like I do the hot water, cold water thing almost every year I have chemistry, unless a student brings me in another direction. So that's already in my repertoire. It's there and ready, and I like it, and it's a great activity. But if a student question drives it in a different direction, and that's where I go. But I have it set that that's going to be in the section where I'm talking about phases of matter and phase changes. I already know that it's going to fit in there somewhere, unless somebody comes up with something else. So do I plan on the fly? Yeah, I plan on the fly. And, when I'm in school, it's not unusual, if a student asks a question and I have to run back into my prep area, be like, oh, wait a minute, I've got a demonstration. I can help answer that question, but I've got to run back and get something. So, I'm prepared to adapt to that every day. And honestly, that's what makes science teaching exciting to me. It's like there are no 2 years that are the same. And I like that.
Perfect. Thank you.
What happens if you don't know the answer? Like you showed a picture of like the snowbank.
Yeah.
Like, where do you go to find your answers?
There are oftentimes I don't know the answer, and I'm not shy to say that. In fact, when I taught both of my daughters in class, and so when my daughter, who graduated in 2006, when she was a senior in physics, she said, you have this really weird habit where anytime somebody asks you a question that you don't know, you say, that's a really good question, but you never say it any other time. And I'm like, and now I'm aware of that. And I still do that for some weird reason. But I think I've changed. When somebody would ask me a question before that I didn't know, I'd go research it, and I'd ask people, and I'd try to find an answer. And I still do that. But if it's a testable question, then I have kids try to set up, well, how would we do an experiment to figure that out? And then we set it up as an experiment. Those types of experiments are way more fun. Now, the snow on the roof, I don't know that that's a testable question. In a situation like that, I'll ask kids to be like, I don't really know why this happened. So let's talk about what we think, and then let's investigate it. And I said, I'll say, I'm gonna just give you an idea. Something you could look up is look up glaciers, because glaciers kind of move like that, where they just kind of slide down a slope. So why don't you find out why glaciers move? And maybe it's the same reason. I don't know. So I usually try to get kids to do the investigation, but I do it myself also. And I'll pose it to other teachers. I'll email it to someone else and say, hey, look at this. What do you think? But but if it's testable, I'd rather set up an experiment to test it.
I had a quick question. Do you try to make your exams open-ended as questions, or do you do multiple choice, or how do you test them if it's based on their fluid questions?
Yeah, that's so, and again, that evolves. My assessment, again, that's not my strong point. I feel like I'm still learning. How do you really truly assess somebody? And it's totally different during COVID right now, but actually, to me, that's one of the silver linings of this. I feel like my assessment techniques have probably evolved more since last March, since we've been in this situation. I should have said, we've been virtual since March. So our district has been virtual since the beginning of the year. Our school board just decided last night we're staying virtual at least till January 15th. And so it has really made me think, how do you assess kids? Because I know they have access to all kinds of information right now. So if I give any kind of test I give them, I know they have the internet. I know they can talk to each other. And instead of fighting that, I just acknowledge that that's out there. And if you want to use that, you can. And so what it's made me do is I haven't really changed the types of questions I ask, but I've changed the way that I assess it, in that what I ask them to do is not, like, let's say it's physics. They still might have to do a mathematical physics problem, but the the assessment is not based on their answer. It's based on them describing to me the process of how they went about solving the problem. So as they're solving it, they need to describe it to me. They need to write it out. And if they're not comfortable writing it, they can contact me, and we can have a verbal, they can do the test verbally as they solve the problem. They can describe to me verbally what they're doing and why they're doing it. I'm fortunate in the sense that I'm in a small district, so I have 17 physics students. So yesterday I was on an assessment call with a kid for 40 minutes, but I can do that because I have a small group of kids. That'd be really tough in a bigger district. But I really like the idea of assessing them based on how they're solving the problems. And a good example of that was yesterday I had a kid who got the wrong answer and he was freaking out. I was like, well, wait a minute, talk me through it. And the problem was a really difficult problem. And there was one step where he forgot to take a square root, and that was it. Otherwise, everything he did was awesome. And so as he walked through the problem, I was able to be like, oh, well, you just forgot to take the square root. That's not a problem. Now keep going. And in my view, he got full credit on that because he understood the concepts. He got tripped up on a little algebra problem, which isn't what I was trying to assess. So I've moved. I don't fully understand standards-based grading. I'm not going to pretend to, but I've moved in that direction. So everything now is scored on a scale from 0 to 4. It's not point-based, and my kids love it. They love that it's not about points. It's not about extra credit. So if they get a grade that they don't like let's say they get a 2, they know that it's not about getting more points to get that to a 3 or 4. They know that they need to convince me that they understand it. And so they can call me, they can email me, they can get a new problem. The grades are fluid in my book. It's about teaching them what the concepts are, and whether they get it in a week or 8 weeks doesn't matter to me. So it's about teaching concepts and assessing on, do you understand the concepts?
I had a
That's awesome.
question.
Thank you.
Oh, sorry. I was wondering, so you're in a very unique situation with a unique group of students, but they're also pretty homogenous is what it seems like, based on you saying about 85% are from the same background. So how would you apply these concepts where you have like a split? Maybe a half is from one background, half is from another, and half of the content might be super relevant to one group and super not relevant to the other. So do you just treat it as a learning experience for both, or how would you suggest overcoming that barrier?
That's a great question. And I'm going to say that not because I don't know the answer. I'm going to say that because again, these are my perspectives, and you'd get a different answer from different people. And you'd probably get a different answer from me if you asked that tomorrow night. But this is what's on my mind right now. That's one of the reasons when I went through those examples of phenomena-based, the phenomena I listed there, besides the maple syruping project, none of those were Anishinaabe focused cultural activities. I do a lot of Anishinaabe focused cultural things because we are homogenous. So we do a lot of food sovereignty experiments or projects. We're on the reservation. I get out of school as often as I can, and we're on the reservation, and we're helping their natural resources division. And a lot of the stuff we do, we talk about their 7 teachings, and we talk about just a huge variety of culturally specific things to the Anishinaabe people because we're homogenous. However, in physics and chemistry, what I do is so that's in my alt-ed program. In physics and chemistry, what I look for and this is actually a result of what kids have told me. I've had so many kids who have now come back and are teaching here. They're students, and they're former students who are now in their 30s. And they said, when I was a kid, I didn't know what it even meant to be Anishinaabe. It wasn't in my mind as a teenager. I really honestly didn't care. I didn't care about my culture. I didn't care about my language. Those things didn't matter to me. I was a teenager. What I cared about was the things all teenagers care about. And so what I try to do in phenomena-based is I just try to think about what are things that they experience every day? They experience water freezing. They experience making ice cubes. They experience slinkies. In chemistry and physics, I'm not looking necessarily for specific Anishinaabe cultured phenomena. I'm looking for phenomena that's relevant to a teenager's daily life. Does that make sense? So and those things are out there. And I have a daughter, my oldest daughter teaches, she's 32. She teaches in Boston, in the Boston public schools. She teaches also, she taught in a what was more heterogeneous setting. She teaches in a public charter school within the Boston public school system, but she's now in a charter within a charter where they're specifically focused on male students of color because that group is their lowest graduation rate. So she is also teaching in a very homogenous group, but it's a homogenous group that is that traditionally has not been successful. And she finds the same success that I'm talking about here. It's not about finding things that are specific to Black teenage males in the city of Boston. It's about things that kids experience every day. That's what turns kids on. Other questions? If you ever, I mean, you should have my contact. Well, Bayfield's little. If you ever have questions or you want to ask me things, or if you can just look up Bayfield School District physics teacher. I'm the only one, so it's easy to find me, and I'd be happy to answer questions. This has been eye-opening for me to look at things from this perspective. I've always thought as a science teacher that I've been doing things in a good way, and I still feel like I have, but recognizing the fact that we need to be more equitable is a big step. And I think you guys, like I said, you guys are way ahead of the game. I don't think that's something that we really talked about before. And so, and it's important to, like I said, to recognize in Wisconsin, we are a very homogenous state. We are, unfortunately, our teaching staff does not represent our student body. And so, and I think that's true across the country. And it's important that we recognize that and do what we can to be as equitable as we can, and to encourage eventually, hopefully, people to come into education. So we do have a teaching staff that resembles our student body.
Thank you so much for coming. This means a lot.
Awesome. Well, don't ever hesitate. I could also talk about union stuff or whatever, but just don't ever hesitate to ask me to come in.
Thank you.
All right. Thanks for asking. You guys have a good night.
Have a good night. Thank you.
All right. Bye-bye.
Okay. Sienna, could you quick pull up the slides? Sorry about that.
No worries at all. Ignore the tabs. I have everybody. It's a very busy time of the semester.
Again, that was Rick Erickson, an amazing and very kind soul. That's not my slide.
Well, I can say it. So,
Go ahead.
Okay, so our lovely outreach coordinator just got news that she is going to be our state board president for the 2021-2022 year, and we're so proud of her, and she's going to do so many amazing things. So we wanted to give a little shout out to Sophie. Yeah.
You're so nice.
So I did in the field this week, and I found a wonderful website called TeacherTube, and it has lots of videos and lesson plan ideas, and I'm pretty sure all of it is free. I didn't personally make an account, but I know you can get things for free because I was like checking out videos, and it seemed super interesting, and they had lots of resources for all different subjects and age levels.
In the world, Kate, I think that's you.
It is me. Just so you all know that this was supposed to be our lovely PR coordinator's slide, but she was not able to join us today. So I'm going to be speaking for Jenna. Her in the world was about the election that I'm sure everyone has heard about. I'm just reading a lot of her stuff and it's kind of funny. Bye bye, Betsy. But yeah, it was a huge win for the education world. We're really excited to see what Joe Biden and the administration that he brings on does for education, and we're really looking forward to it.
In Madison, there's two kind of education related weeks going on this week. So one is International Ed Week being held through the School of Ed's Global Affairs Office. And there's a couple cool Zoom calls about international education that you can join. If you just go to the Global Affairs Office, you can find all the links for that. And then this is also American Education Week. So NEA has a couple fun Zooms going on this week and interactive activities that you can participate in. And if you do participate in them on your social media, you should tag us and we will give you kudos and stuff like that.
Oop.
I am pumped for a trivia. It is $5 a person. It is this Friday at 7 o'clock. And if it is too late for you to form a team, we are taking individual applications. Not applications, but like you can sign up individually and either you can play by yourself if you want to play by yourself, or you can be in a group of just other people who've signed up, who have marked that they want to be in a group, but are signing up individually. Does that kind of make sense? Or did I confuse? That kind of makes sense? Good. Okay. $5 person and Venmo it to UW-Madison aspiring educators. And I'm just saying, you think you know the 2000s, but this will make your head spin.
And
And also just to highlight,
oh,
I keep talking over everyone. I'm so sorry.
You go, Kate.
I was just gonna say, just to highlight that the Zoom link is attached to the slides, but it'll also be in our follow-up for those who are joining us for trivia night.
all right, are we good? Okay.
This is our Thanksgiving fundraiser. We are raising money to be donated for the Goodman community to help them donate money towards the Goodman community holiday baskets. So 90% of the proceeds will go to them, and then 10% will go towards aspiring ed and funding future WEAC members.
We've already made $71. Yay!
You can take this picture right off the slideshow and post it on your social media. We want donations by November 24th. It's kind of like the sorority bingo card that you see. I'm so sorry, Sienna. Next one.
It's okay. I can't see like any Zoom faces, so maybe this is my bad.
This is our teacher's clothes. So you can get a t-shirt, which is $20. This crew neck is $30, and these sweatpants are $35. I've attached the link and the QR code. If I'm taking orders through, I think it's December, I'm blanking on it. It's 2 weeks from today. So you get 2 weeks, and your clothes should be delivered by the holidays. So I'm sending it to my parents' house. And I think there's one more shirt. Yes, there is. Good. On the next one. I got ahead of myself. This is the teacher themed idea. If you're like, I have too much UW clothes, I understand. Here is the teacher shirt of the year. You get a choice of these 3 colors. And then we ask that you Venmo UW-Madison $25. And then with this one, you need to fill out the survey, which is attached. And it's asking for your size, and this one doesn't include free shipping. So we will either be doing a drop off, or you'll be picking up the shirt at like a safe location, or probably we'll just drop it off. But this one is 2 weeks too.
Is the QR code, Mary, to order the shirt? Like, is that the form?
You are submitting this Google form shirt to order the shirt. And then I'm placing a generic order. So we buy the shirts in bulk.
Cool.
Outreach is a little different this week. So instead of it being a speaker in the Madison area that is virtual, these are some Instagram things that you should follow for all things education. There's all this teacher content all the time from all these sites, and they give you alerts to interesting seminars, and some of them are more specific to certain kinds of educators. So it's really helpful to know when those are going on. Literally, they all have a seminar going on right now. So, and I found out about it yesterday. So follow all of these to get everything you need to know about education.
We're also selling stickers in addition to all the other things we're selling. So these are the 4 stickers we have available, teacher stickers, if you're interested. Each sticker is $2. If you click on this picture, it will take you to a Google form to, a Google form to order your stickers. It details all the instructions and how to order the stickers on there. Just so you know, that Google Forms checked every Tuesday. So if you place your order in the Google form on Wednesday, it obviously won't be checked until the following Tuesday. So give yourself about a week to 2 for those stickers to come in the mail. Just so you know, for planning purposes, or if you're gifting the stickers. Postage is covered. And you can order as many stickers as you want until supplies run out. Let me know if you have any additional questions.
Okay, so like last meeting, I talked about how the president-elect election is coming up, and we have a little bit more info this time. So we are starting to accept submissions for the President of Aspiring Ed for the Madison chapter for the year 2021, 2022. We're starting to accept submissions December 12th, and there are 2 Google documents that you can look at and fill out. So the first document is just an overview of the expectations of the president, as well as being part of the e-board. So if you wanted to know what your responsibilities might look like. And then the presidency form is the bolded one, and it has all the instructions of what to do if you would like to run for president. And the deadline is January 16th at 11:59 p.m. You will send your presidency form to our Gmail, the Aspiring Educators UW Gmail. If you have any questions, please feel free to reach out to any of us or email the Aspiring Ed email. So yeah.
Mentor program. If you are a part of the mentor program, we have a little update survey on how it's going. You just click the link, it's attached here. It'll also be in the follow-up email. We just want to see how it's going so far in forming your friendships. This form for those in the mentor program, it starts off anonymous. You have an option to put your name if you want, not required though, so please be honest. We want to see how it's going, what we can improve, or what you really enjoy. A part of the form that I want to highlight is there's a part where it asks if you would be interested in attending a virtual event over winter break. Please let us know if you're interested, because I would like to plan that virtual event for everybody if we're interested in it, but I don't want to plan it if nobody wants to come. So that's that. It's due by the 23rd, which I think is, oh, I just realized I put a TH after that. Sorry, guys. It's been a rough week. I think that's next week, Monday, Tuesday, one of those days. It's
Next week, Monday.
Monday. Thanks, Kate.
I'm really excited about this one, guys. So Aspiring Educators UW-Madison has an official website now. And what is on this website? A link to all the beautiful merch Mary talked about and instructions on how to order it and how to pay for it. book club information, which is after this meeting, links to all of Mary's amazing fundraisers, and hopefully the link works, or else that would be embarrassing, but it seems to work. So this is our website. So you can please check it out. This thing, I'm not the most tech savvy person in the world, so very proud that this thing came together. This is our Instagram, so our Instagram posts are accessible. On the contact page, it has all of our social medias, our email, and a form that will automatically fill out an email. Yeah, this is really cool. So if you ever want to send us an email and you don't want to have to deal with writing out the email, or you don't know how to contact us in a very efficient way, all you need to do is put your name in the field, kind of your own email, so we can reach back to you, and the message, and Chloe will get that. So that's exciting. But please check it out. Share it with your friends who are in education. Yeah, it's exciting stuff.
The merch is here too, if you don't want to go back to the PowerPoint.
And at the bottom, if you're having questions, there's another little fill in, your name, email, and any issues you're having with merchandise and that kind of stuff. So if you have any questions, let me know. And if you notice any glitches, let me know.
Oh, cool, it worked. Our next meeting is December 1st, which, believe it or not, is our last one of the semester, y'all. We're there almost. We almost made it. So feel free to come. Jenna's planning it. It's going to be awesome. Follow us on social media.
Yep, that is the Sienna, it's my goal to interrupt you. You never know. It really is. I woke up and said I want to interrupt Sienna every time she talks. So you're welcome. No, for the sake of time, I'm gonna say we are concluding our meeting. Thank you to everyone who came. We really appreciate you sticking it out for a full hour. I think that is our record long meeting, but there's a lot of cool information. The follow-up will be sent out either tonight or tomorrow, along with the video of this meeting. If you are staying for the book club, you can just stay on the meeting. Otherwise, that is the concluding November 17th Aspiring Ed meeting. So goodbye, everybody.